This chapter will give you an introduction to the principle used for creating electronic charts, make you understand the limitations involved with the different methods used to create electronic charts, and how to minimize the effect of these limitations. Charting and mapping organizations, as well as private companies, were early users of computer graphics to automate their chart and map production. The aim was to increase production efficiency and to reduce costs. Until a few years ago, the final product, however, was the same printed paper charts. Position-related information about a landscape is referred to as geographical data. The main element of geographical data is geometric data, that is, description of position, size and shape of the objects located in the landscape. Lighthouses, houses, buoys, etc. Geometric data can be stored digitally in two different ways, as raster data or vector data. An electronic navigational chart. What is it? The understanding of this expression varied very much, and the need for better definitions resulted in some standard terms accepted by IMO. IMO standard terms used in connection with electronic chart production and their use are found in IMO Resolution A817-19. The definition of an electronic chart database, abbreviated ECDB, is: an ECDB is a master database of chart information held in digital form by a national hydrographic authority. The definition of an electronic navigational chart, abbreviated ENC, is: an ENC is a subset of the ECDB held on a vessel. It contains useful information for navigation such as coastlines, lighthouses, beacons, etc. An electronic chart is constructed using either raster data or vector data. Scanning the master components used in the production of a paper chart produces raster data. The resultant image is made up of a number of lines, which in turn are made up of a large number of coloured dots or pixels. A raster chart is simply a digital facsimile of a paper chart, and so it is not possible to interrogate the raster data to obtain information about any object on the chart. Raster data is therefore considered to be unintelligent data. Giving digital values to each and every object on the chart produces vector data. These values enable a computer system to identify the object, to portray it in the required form and colour, to place it in its correct position, and to provide information about its attributes. It is therefore possible to interrogate a vector chart in order to obtain information about charted objects and to enable alarms to be raised when potentially unsafe situations occur. Vector charts can be customized and are therefore considered to represent intelligent data. The availability of officially approved electronic charts is very limited, and this situation is likely to continue for a long time. This is a fact that must be fully taken into consideration when using electronic chart and electronic chart systems. The accuracy of data on a raster chart is exactly the same as that of an official paper chart, since the data depicted is identical. Electronic chart systems used to display raster charts convert the WGS84 coordinates obtained from a GPS receiver into coordinates referenced to the datum of the relevant raster chart. WGS84 shift data for significant areas of the world will not be available for some time. Currently, geodetic survey data is available to compute the relationship between WGS84 and local datum for about 60% of Admiralty charts. The worst known difference between the local datum and WGS84 is in the order of 7 nautical miles, and differences of several hundred meters are not uncommon. Navigators requiring using a chart for which no WGS84 shift information is available should use GPS positions with extreme caution. They should first establish the relationship between the chart datum, WGS84, by taking visual and/or radar fixes of shore features. This will provide a means of adjusting the GPS position to fit locally on the chart. Datum transformation parameters, such as those built into a number of GPS receivers, should be used with caution. These transformation parameters may be based on limited or provisional data, or they may represent an average across a wide area. Errors in the range of hundreds of meters could occur when using the GPS in the following areas. Areas which are at the extremity of datum coverage. Areas where geometric control is weak. Areas where survey data is too old. Navigators should take particular care when using the scale or zoom facility in the electronic chart system. It is all too easy to zoom in and effectively select a larger scale than the one used for the compilation of the data. This could create a false impression about the reliability of the charted data. Regular checks should be made to ensure that the scale selected on the electronic chart system is the same as that on the equivalent official paper chart. The high-tech appearance of an electronic raster chart interfaced with systems such as GPS can easily mislead the user into the belief that the charted data is more accurate than is really the case. It will be many years before a significant number of raster charts exist with accuracy, similar to that provided by DGPS. Until then, navigators must take particular care to assess the accuracy of the data presented to them by these raster charts. The IMO performance standards for Ectis state that information to be used in Ectis should be the latest edition of information originated by a government-authorised hydrographic office and conform to standards laid down by IHO. This means that officially approved vector charts must be used in an Ectis. Since few officially approved vector charts exist, navigators using commercially produced vector charts must work on the principle that the data on a corrected official paper chart is more reliable than that on the corresponding vector chart. Non-official approved electronic charts are available from a variety of sources. For example, the LTK Hydrographic Office's Admiralty Raster Chart Service, ARCS, provides worldwide coverage with a series of about 2,500 raster charts. Commercial chart providers such as Transas Marine and CMAP claim to provide near worldwide coverage with a series of vector charts. On the following pages, you will be asked some questions.